Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a really nice problem, a really nice equation with complex numbers. So we have a plus bi to the second power equals b plus ai. And we're going to be solving for a and b values. Now, where does this problem come from? Well, this problem was suggested in the comment section. Thank you, NobodyMan181. for suggesting a problem like this, and I will always appreciate suggestions. You can just comment or use the form in the description. So let's go ahead and solve this problem and answer this question. So we have a plus bi to the second power being equal to b plus ai. Remember, previously we just talked about a power that turns a complex number to its conjugate. And guess what? We can do this in the general form too, but that's going to be later. Anyways, let's go ahead and take a look at this equation. We can go ahead and square the left-hand side, and that's going to be a squared minus b squared from bi squared. It's negative b squared because I squared is negative 1, plus 2abi equals b plus ai. Now, when two complex numbers are equal, you kind of have to think of two things. Their real parts are going to be equal, and the imaginary parts are going to be equal. Let me go ahead and illustrate that real quick. So we had 2abi here, and we have ai here. So in this case, the real parts are in yellow, a squared minus b squared. That's going to equal b. So a squared minus b squared equals b. And the imaginary parts are 2ab and a. So they're going to be equal as well. This gives us a system of equations. It's kind of quadratic, and there are two variables and two equations, and we can solve it. All right, let's go ahead and solve it. Since the second equation looks simpler, I'll start with that. Let's go ahead, and by the way, don't do this. If you have an equation, don't divide both sides by a variable. You can divide by a number, but not a variable, because you're going to be losing some solutions. So don't do it. Instead, put everything on the same side. 2ab minus a equals 0, and then factor out the a, 2b or not 2b minus 1 equals 0. All right, now this gives us two things. Either a is equal to 0, which means two things. So one of them is going to be a equals 0, and that's just going to mean if you plug it into the first equation, that's going to give you negative b squared equals b, or b squared plus b equals 0, or b times b plus 1 equals 0. And that means two things: b is equal to 0, or b is equal to negative 1. Make sense? You can definitely test these out, or plug it into the original equation to see if they're going to work. But from here we got a equals 0, b equals 0 works, which means z equals 0 is a solution because both parts are 0. And another solution would be 0 minus 1i, or just negative I. Again, you can test it out. We can do that. But that's basically what it is. Make sense? This is the first part from a equals 0. Now, what happens with the second factor? 2b minus 1 equals 0. That means b is equal to 1/2. So we can kind of bullet point these to indicate, okay, we're solving two cases here. The second case is b equals 1/2. And that implies from the first equation, a squared minus 1/4 is equal to 1/2. And that implies a squared is equal to 1/4 plus 2/4, which is 3/4. And that implies two things. A is equal to root 3 over 2, or a is equal to the opposite of that. And those numbers should be familiar to you. Think about cosine and sine of some special angles. Does that look familiar? I hope so. Now, those are the values we found based upon this value. b equals 1/2. Along with these, that's going to give us other ordered pairs for a and b, right? Just like this one. Cool, cool. Let's go ahead and put it together. Then we could call this z sub 1, z sub 2. Z sub 3 is just going to be root 3 over 2 plus 1/2 I. And z sub 4 is going to be negative root 3 over 2 plus 1/2 I. Notice that the imaginary part is always positive in this case. Make sense? Okay, so looks like there are 4 solutions to this equation. Are those all the solutions? Can we find other solutions? By the way, you can basically test it out How? Well, we just said that, okay, if a is equal to, let's go ahead and check one of these, like 0 definitely is going to work because 0 squared is 0. But what about negative I? Do you think negative I is going to work? Well, what is negative I? It came from 0 plus negative 1i, which means a is 0 and b is negative 1, right? So we need to test the a, b values. If a is 0 and b is negative 1, we're going to get this. Is that the same thing as negative 1 plus 0i? Negative I squared is I squared, and I squared is negative 1. All good. Yes, that definitely works. What about the other ones? The other ones are going to be a little harder to check. But let me tell you something. Let's go ahead and take z sub 3, for example. That's kind of like a fun one, and the other one too. But root 3 over 2 plus 1/2 I. By the way, these numbers have a really nice property, and you can verify that by doing the absolute values. Their modulus is always 1. Because if you do absolute values on both sides in the original equation, you're going to get that, right? Do you? I don't know, maybe. Anyways, this is what I wanted to talk about. These are the cosine and sine values. So this is like cosine of 30 degrees or pi over 6. And this is going to be sine of 30 degrees or sine of pi over 6. Make sense? So in other words, z sub 3 can actually be written as e to the power I times pi over 6 in polar form. Does that help if for substitution? Yes, it kind of does. What happens here is, let me tell you, we take that number, we square it, and by squaring, obviously, you're doubling the argument, which is the angle, right? The theta. And that just switches these numbers around, because if you think about it, cosine 30 is the same as sine 60 and vice versa. Make sense? That's why this way of approaching the problem works, and easily you can verify it. What about the other one? That's for you to find out. But if you think about the argand plane where cosine is negative and sine is positive, you're basically in the second quadrant. So think about reflections and then put this number in the second quadrant and then square it, which is obviously gonna give it some type of rotation, right? In other words, like you're multiplying it by itself. And then you can kind of see what happens. Or you can just directly square this number to see if you're going to get what's on the right-hand side. Make sense? Okay, so you can definitely go ahead and check it out, but those are going to be all the solutions. Looks like we have 4 solutions. This kind of looked like a quadratic equation to me, but we ended up 4 solutions because complex numbers are always weird, right? They're full of surprises. Another thing that I thought about, which is probably not going to help, but I thought about replacing this with z. Then what are you going to replace this with, right? Maybe zi or negative zi or something like that. Explore it. Anyways, this pretty much brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.